Greetings viewers, in this video we'll attempt Cambridge A-Level Further Maths, Component 3 Further Mechanics. This is variant 3 from May-June 2025 series. We'll go for question 3. The previous question uploaded into the playlist already. This question involved a ball projected vertically upwards with an initial speed of u, and it moves under gravity. So we just draw. So you have a ball, then we project it upwards vertically with a speed of u. At the time t after projection, it has a distance of x and a speed of v. There is a resistive force of magnitude mkv squared newtons, where k is a positive constant. So let's look at the force balance first. In the free body diagram, we're going to have the ball, and we have the weight mg, and we also have the resistive force mkv squared. And so if we take upwards as the positive y, then these two are negative, and there will be a resultant force because it is not balanced and it will accelerate downwards. So there will be a negative mg, negative mkv. This is the sum of forces in y equals to ma. Okay, so negative mg, negative mkv equals to ma. All the m cancel out, and a also, if you recall from the kinematic, a can be written as dv dt, the change of velocity with respect to time. And I'll cancel out all the m here. We get this expression dv dt and v here, but we want to get the distance x, but there's no variable relating that. But what we can do is we take this dv dt, we use the chain rule to rewrite it as dv dx and dx dt, sorry. So dx dt, that's velocity, and we can replace this down here also. Now we can perform the integration. We can separate the variables here. On the left hand side, the integration is fairly simple. It's just the integral and the differential cancels each other, so you just get a negative x. On the right hand side, sorry, we're going to need a substitution. Just erase this first. If you can notice, the top and the bottom, the top is can be kind of manipulated in a sense to become the derivative of the bottom. We're going to let u equals to the bottom function, kv squared plus g. So g is a constant, k is a constant here. When we differentiate, du will just become 2v, 2kv dv. G becomes just 0 because it's a constant. And we can isolate dv from this. dv will just be du over 2kv. And now we can substitute everything back into our integral, so it transforms into the u variable. So this v and v cancels out. 2k is just a constant, so I'll just pull it out of the integral. K is a constant, so it does not interfere with this. And we're left with 1 over u du negative x. 1 over u, that's just, you take the integral, that's just a natural log. So natural log of u. U we have already assigned just now, that is kv squared plus g. So we're just going to do this. Substitute it back directly. And we don't have to put a modulus because v squared will always be positive, k is a positive constant, g is a positive constant also, is 10. So we don't have to worry about the modulus there, and we have a negative x. Right, then we have a plus c. After we done the integral, so we have a constant here. And what's the initial condition that we have? At initial speed is u when the displacement is 0. So initially displacement is 0 and the speed is u. So x equals to 0, v equals to u. So we're going to do this substitution here. And so we are able to get the constant to be a negative 1 over 2k natural log of ku squared. This is a u. Not so good using v and u here. But anyway, this is our constant, and we'll substitute this back into the function or the expression that we got just now. And we can factor out this 1 over 2k and also cancel out the negative on the left hand side by multiplying the whole equation by negative. In using the logarithm rules, we can, this is a subtraction of log, and I can make it into become a quotient. So, and this is exactly what they've given us at the question. So this we have proven this lah. For part B, it's given that k, okay, they give a value for the constant k and also the initial speed u20. And they want us to find the time taken for the ball to reach its maximum height. And so when the ball is projected from the ground at the maximum height, it will have the instantaneous speed to be 0, right? Then it will change direction to come back down. So we want to find the point where at maximum height, then v is instantaneously 0. Then we want to find what is the t for this to occur. Let's go back to what equation that we have. We can come back to this one. Because we have a relation of velocity and time. And yeah, g and k are constants, so that we have this constant, so let's do that. So we're just going to copy down the equation. Okay, this is from question 1 already, from the force balance, right? And we know the value of g is, okay, g we use 10 in this syllabus, not 9.81. K is 0.025, and v squared dv dt. Here we can just separate the variables so that we have a dv over 0.025 v squared 10, and here we have a dt. So these are both integral on the both sides. On the left hand side, negative dt integral, the integral and differential just cancel, so you get negative t. On the right hand side, we need to do a bit of manipulation. First, maybe I want to get rid of this 10 so that it's just a plus 1 behind. So I'll take the 10 out of the integral 1 over 10. So it becomes this equation. And 0.0025, we can rewrite that as 1 over 400. So it's easier to look, or it's easier to do some manipulation this way. 400, we can notice, is also 20 squared, which is type of an integral here. Let's say we have this form, 1 plus x squared. Now x in this case, we can set it as u equals to v over 20, so that u squared is v squared over 400, and also du is 1 over 20 dv. So dv is 20 du. Just write it down. dv is 20 du, and we can substitute all this back into our equation or the integral, so that we transform this entire integral, the variable, from v to u. Okay, so the dv we change, and the 1 over 400, the v square we change. This is supposed to be u squared. We can cancel out, do some cancelling. So you're left with just du over u squared plus 1, which gives us, using this formula again, an inverse tangent of u. And u we've said it previously as v over 20. So that's the substitution. We're going to sub it back like that. And we have a negative t equals to this. So we have done our integral, we add the plus c behind. Okay, now what information do we have to use? We know that u is 20. This is the initial speed, meaning at t equals to 0, initial speed lah. So v equals to u, which is equal to 20. Is it 20? Yeah. So 0, and then tangent inverse of 1. C will be pi over 2. Okay, inverse tangent of 1, that's pi over 4, multiplied 2, that's pi over 2. Negative, because we move to the other side. And we substitute back into the equation. Negative t equals to 2 tangent inverse v20 minus pi over 2. And then if we get t as a function of velocity. So pi over 2 minus the 2 tangent inverse v over 20. Okay, and we want to find the time taken for the ball to reach the maximum height. We have t as a function of u, so we just need to sub in v equals to 0. We've established at the maximum height, the velocity will instantaneously be 0. So we're just left, okay, tangent inverse of 0 is 0. And because tangent 0 is 0, so we're just left with the pi over 2 seconds. So the unit is seconds. That will be our final answer for this question. Okay, thanks for watching.